Hello, welcome here to another edition of the GTC Studios, and you are with Eunice. Today I'm going to talk about a very important concept in chemistry, and that is enthalpy. When you hear the word enthalpy, what do you think of? Do you think of it as heat, or do you think of it as calculations, hard calculations that cause you to sweat? Now, the person who thinks about enthalpy as hard calculations may never understand it. But one who thinks of it as simple heat, a four-letter word, will understand it better. What is enthalpy? Enthalpy is the heat of a body that is contained in its bonds. When you have carbon with oxygen, this line within there is what we call the bonds. Now this bond is formed or broken using heat, and that shows that there is heat in this carbon and oxygen bond. So enthalpy is heat that is in bonds. In this topic, we are going to meet very many symbols. We have delta H here. Delta H stands for heat change. Now, delta H, or enthalpy change, is divided into two components. We have positive delta H here, and that means an endothermic reaction. And that reaction takes place when bonds are being broken. Now, bonds are very strong things, and when you break them, you require a lot of energy, and that energy is got from the surrounding. When a bond, for example, a bond between carbon and oxygen is being broken, it requires a lot of energy. Come to think of it. When you put sugar in this cup of tea, what do you expect to happen? The tea will become cooler. And that is because sugar has taken some heat from the tea in order to break down as it's being dissolved. And that is what we call enthalpy. The bonds in this sugar particle are being broken, and that requires heat from the tea. And we also have this negative delta H, and in this one we talk about exothermic reactions. And in these reactions, heat is being given out, and that means bonds are being formed. Heat is produced to the surrounding. Let's look at this athlete. When she's running, she feels heat radiating from her body. Even when she stops running, heat is still radiating from her body. That means bonds are being formed as she's running. Bonds are formed between carbon and oxygen. Carbon reacts with oxygen to form the carbon dioxide that this athlete gives out, and that leads to radiation of heat. And as she's resting here, heat comes out of her body. Now, let's look at the types of enthalpy. We have the enthalpy of combustion, and this is the energy change when a substance is being burnt in oxygen. Now let's take a very common example here. We have carbon being burnt in oxygen to form carbon dioxide. And what happens is that heat is released. You see the delta H here is negative. So heat is being released, and it releases a very large amount of heat of 393 kilojoules. Have you ever wondered why charcoal stoves produce heat? Have you ever thought of it to ask your parents or someone why this charcoal stove is used for cooking? It's because it produces heat, and that happens because carbon in the charcoal is being burnt in oxygen to produce heat, and that gives you the warmth and the heat. Why do you think people go to fires? Why do you think people in camps light fires? It's because carbon reacts with oxygen to produce heat, and that keeps the people warm. Then another example, another type of enthalpy is enthalpy of solution. And that is enthalpy change when 1 mole of a substance is dissolved in sufficient water such that no further change occurs in dilution. What do we mean by that? When 1 mole of a substance, such as 1 mole of sugar, is dissolved in water, what do you mean by no further change occurs? This last statement, no further change occurs in dilution. That means no further heat change occurs. That means no further bonds are being broken. So enthalpy of solution occurs when 1 mole dissolves in heat and it dissolves in water, and that means bonds are being broken as it's being dissolved. As you've seen in the sugar in the tea, bonds are being broken. And so this enthalpy change is going to be positive delta H, because it's going to require a lot of heat to break those bonds between sugar as it dissolves in water. And so the whole of it has to dissolve, so that if you happen to add any more water, you will not find any more heat change. And that's when enthalpy of solution takes place. Let's also look at the enthalpy of neutralization. This is very important. This is the enthalpy change when 1 mole of hydrogen ions in aqueous solution reacts with 1 mole of aqueous hydroxide ions to form 1 mole of water. And the equation is as follows. We have hydroxide ions here. And hydroxide ions. We have hydroxide ions which react with oxygen, with hydrogen ions to give you water. What do we mean by 1 mole? 1 mole means only, as you can see here, this is only 1 mole of hydroxide ions reacting with 1 mole of hydrogen ions to give you 1 mole of water. And since you see the bonds are being formed between hydroxide and hydrogen, this reaction is going to be negative delta H. That means heat is being produced in this reaction. So let's look at our last type for this session. We have the enthalpy of displacement. Enthalpy of displacement is the enthalpy change when one element displaces another in its compound. Now that only happens when the element that is displacing the other one is higher in the reactivity series than the element that is in the compound. Take an example. A big man will push away a small man from the chair. So this zinc, which is higher in the reactivity series, is going to push away the copper in this compound to give you copper solid plus zinc sulfate. So zinc, 1 mole of zinc will react with 1 mole of copper to sulfate to give you copper solid and zinc to sulfate. You see, zinc has displaced copper from the sulfate. So copper comes out as a solid. And when we look at this reaction, is it negative or positive delta H? As you can see, bonds in this reaction, bonds are being broken and also being formed. If we have bonds being broken as negative delta H and bonds being formed as positive delta H, what will be the resultant delta H? It all depends on the amount of negative and the amount of positive delta H. So that's what happens when a substance is being displaced from its compound, and heat is always produced in such a reaction. There are very many other types of heat change. We have the enthalpy of ionization, which is the enthalpy when an element loses an electron to form an ion. So we have this element M, it loses its outermost electron. It loses its outermost electron to form M+. And that is what we call enthalpy of ionization. Well, enthalpy of formation is when 2 ions come together to form, to form a substance. We have this sodium ion. It comes with a chloride ion to form sodium chloride. Sodium chloride, which is the salt you normally eat. Thank you very much. This will be the